Simply supported beam subjected to a point load at the middle. You can see here simply supported beam subject to point load at the middle. Okay, at the middle exactly at a distance of L by 2 from either ends. So sigma MA is equal to 0 right in the moment equations. Okay, W into L by 2 clockwise positive minus RB into L anticlockwise negative. So you can find, you know how to write out the moment equations you would have studied from engineering mechanics chapter, sorry, subject. So RB is equal to W by 2. RB is equal to W by 2. So writing the vertical equation, vertical force equation, sigma Fy is equal to 0. RA and RB both are acting upwards. So RA plus RB, W is acting downward minus W. Substitute RB there, you will get RA is equal to W by 2. Now we have got the unknown support reaction values, RA and RB, which are both are equal W by 2 because the load is acting exactly at the middle, symmetric load. So the load divided by the number of supports 2, you get RA is equal to RB is equal to W by 2. With this, we are going to plot the shear force diagram. And this is the baseline or reference line in which we are going to plot the shear force diagram. Okay, so uh, this on this line, the baseline or reference line, the shear force values would be 0. On the top or above this line, positive values will be plotted. Below this line, negative values will be plotted. Okay, so the vertical reactions will be shown by a vertical line in the case of a shear force diagram. Okay, vertical lines. Okay, depending on the direction of the loads, the vertical line can move upward or downward. Okay, now let us consider some section x at a distance x from the left hand support A. Okay, shear force about xx. Now this is our section xx. I have to consider what all the forces are acting to the left side of the section xx. I have to consider. So left side of the section xx, we are having only one unknown support reaction Ra. Okay, the shear force unit is Newton. Okay, Ra is also having Newton. So both are dimensionally balanced. Okay, so left hand side you are having force Ra. So left hand side Ra is acting upward. So positive. So RA is nothing but W by 2. So the shear force at A is W by 2, which is positive, will be marked above this reference line, acting upward. So this is nothing but W by 2. So this magnitude is nothing but W by 2. It should be shown by the vertical increment because it is acting upward. Downward means it should show by a vertical line decrement. From A to C, no load is acting, no load is acting. So it is a horizontal line, which means that shear force remains constant between A and C. Shear force remains constant at A and C. Once we reach the point C, a point load of W is acting downward. This is nothing but W by 2. Okay, once I reach point C, W is acting downward. So which means that W by 2 we are having already, and here when I reach the point C, W is acting downward, so minus W. So W by 2 minus W is nothing but minus W by 2. So the shear force at C is nothing but minus W by 2. Okay, so that is, this is a 0, this is plus W by 2, and this is minus W by 2. So W by 2 plus W by 2 will be equal to W. Okay, like this you can check. And between C and B, no loads are acting again. The shear force remains constant. Okay, so as I told you already, you can proceed from right hand side also. When I proceed from right hand side, RB is acting upward. Okay, which means negative. RB is nothing but W by 2. So it should be marked below the reference line. So this is nothing but minus W by 2. You can just draw a line to complete your shear force diagram. So this is the positive value, this is the negative value. So plus W by 2 here, minus W by 2. So when a simply supported beam subjected to point at the middle, the maximum shear force is plus W by 2. That we need to remember in our mind. Next, how to plot the bending moment diagram. Okay, so now I'm taking a section as it is. Okay, force into distance is the moment. Okay, so Ra into x from the left hand side, Ra into x from the left hand side clockwise is positive, Ra into x. So at A, x is equal to 0. Substitute here x is equal to 0, you will get bending moment is 0. So that's why I told in the important points, always the bending moment 0, at the simply supported ends. So here the bending moment will be 0. That is, if you take this as a baseline, here the bending moment will be 0. Then at L by 2, at x is equal to L by 2, substitute x is equal to L by 2 here, you will get W by 2 into L by 2, WL by 4, which is the bending moment at point C. Okay, so this is the baseline. Here the bending moment is 0. Okay, so the nature of the bending moment diagram for a point load is a triangle. Okay, so here the bending moment is 0. At C, it is a WL by 4. Simply draw a straight line. Okay, we know that here again the load is symmetrically, I mean the beam is symmetrically loaded. Okay, so at the simply supported end, we know that the bending moment is 0 here. Between C and B, there is no load. I can easily connect from C to B, right? I mean from maximum to this B point. Okay, so this is the bending moment diagram. So the maximum value of bending moment is WL by 4 for a simply supported beam subjected to a point load at the middle. Okay, so this is the shear force diagram and this is the bending moment diagram. Again, you can see here the shear force is 0, but the bending moment is maximum. Here the bending moment is 0, the shear force is maximum. That we need to understand.